So this video is going to build on what we learned about when we talked about polar covalent bonds to introduce you to hydrogen bonds. So hydrogen bonds form between polar molecules that, as the name implies, contain a hydrogen atom. A great example of this, one that you're already familiar with, is water, right? It's a polar molecule for reasons that we talked about in a previous video. And it contains hydrogen atoms, and so water molecules tend to have hydrogen bonds between them. One of the things that I want to say about hydrogen bonds that sets them apart from an ionic bond or a covalent bond or a polar covalent bond is that there is no exchanging, no sharing of electrons in this type of bond. What it is actually is a magnetic interaction that's happening again between these polar molecules. So we previously talked about water molecules and the fact that they've got this end, the oxygen end, which is a little bit more electron dense, and because of that it has a partial negative charge. And we've got this hydrogen end of the molecule that's a little bit more proton dense because it doesn't have the electrons equally, and so it's got a little bit of a partial charge to it. So we've got a polar molecule, it contains hydrogen, and it has this magnetic interaction with other water molecules. I want to draw this out for you and show you why. So let's imagine we've got a little drop of water, and I'm going to draw in several water molecules that are making up this little drop of water. Here we've got a water molecule with a positive end. This is the negative end of another water molecule. There is going to be a magnetic attraction between those two ends. So this water molecule and that water molecule are going to cling together just like the ends of a magnet would. Over here, again, we've got a positive end there and a negative end here. These water molecules, opposites attract, right, are going to want to cling together. This positive end is going to be attracted to that negative end. And so we're going to have all of these water molecules kind of cohesing down into the smallest possible space, and they're being held together literally just like magnets will kind of bind together and hold each other together. This is actually a property of water molecules, which is known as cohesion. So cohesion is the tendency of water molecules to kind of bind, attract, not really bind because they're not sharing or exchanging electrons, but attract to other water molecules and tend to kind of hold together in these little cohesive units. That's what's responsible for raindrops, right? So when rain falls from the sky, it falls in these little cohesive units that are being held together by the hydrogen bonds. It doesn't fall as individual, separate little water molecules that are coming down from the sky. So that's the property of cohesion that we see with water molecules because they're held together by hydrogen bonds. The other thing that you'll see, the other property that water has is what's known as adhesion. So you have probably seen, here's my terrible drawing of a blade of grass. A blade of grass. And if you get up in the morning, you may notice little dewdrops, right, on the blades of grass. And the reason for that is because water is polar, because it has these oppositely charged ends, it tends to cling to anything else that is also polar. So there must be some polar chemical, something that's polar in blades of grass that's going to cause these little drops of dew to actually attach to the grass blades. And this is a property of water that's known as adhesion. So it tends to stick to things also that aren't water because of the fact that it has this little magnetic ends, basically.